Let's do an example problem. If a person has a weight of 125 pounds, what is their mass in kilograms? So let's see. Person has a weight of 125 pounds. Let's see. Maybe I'll do that. So 125 pounds. And there are 4.44 newtons per pound. And I need a calculator. Let's see. Okay, there it is. Kind of a large calculator. So 125 times 4.44 equals. So that's around 555 newtons. And mass in kilograms, mass is going to be the force of the weight divided by acceleration due to gravity. So 555 newtons divided by 9.8 kilograms per newton. Or I'm sorry, that is not kilograms per newton. Just get me over here. That is newtons per kilogram. The newtons divide out. 1 over kilograms is kilograms. And if I divide that, .8, I'm going to get about 56.6 kilograms. Okay, so 125 pounds is about 555 newtons, is about 56.6 kilograms near the surface of the Earth. Okay, let's try some more. So here they are doing the problem. They use 4.448. I use 4.44. So they get one more newton, but it's the same idea. And since the force of the weight is equal to mass times gravity, mass is equal to the force of the weight divided by gravity. And the same thing happens here. Newtons cancel out and you're left with kilograms. Whenever you know the mass of an object, you can calculate its weight. Whenever you know the weight of an object, you can calculate its mass. What's common to both, of course, is the acceleration due to gravity. You have to know that. So what are you? Write on a paper. You can hand in, write down your weight in pounds. If you do not want to share, use 100 pounds. Convert your weights from pounds to newtons, find your mass, and using the chart on the worksheet, that's at the end of this, calculate your weight on any 3 planets. You guys will get the worksheet in a little while, or you've gotten it already. And let's see. I'm going to use 100 pounds. So let's see here. Oops, there was something I didn't erase from before. Going to get that now. Okay. So if my weight is 100 pounds, I'd like to express that in newtons. And since there's 4.44 4.8 newtons is 1 pound. In order to get rid of pounds, I'm going to have a conversion factor where pounds is in the denominator. I'm going to divide both sides by 1 pound. Anything divided by itself is just 1, which tells you immediately why we can multiply our number by this crazy thing and not have it change, because really our number is just 1 in disguise. So 4.448 newtons per 1 pound. Pounds divide out, and we're left with 444.8 newtons. So we converted from pounds to newtons. Next, we might want to find out how much mass do we have. Well, if we're near the surface of the Earth, and I guess we are, we're going to say that mass is equal to the force of our weight divided by gravity. Force of our weight is 444.8 newtons over 9.8 newtons per kilogram. The newtons divide out, we're left with kilograms. And so 444.8 just going to move me 444.8 divided by 9.8 is equal to about 45.4 kilograms. And so what would be my weight on another planet? Well, let's see what choices we have here. I'm going to try, I think, Mars, which is a little less than 4/10 of what it is here on the Earth. So it's 3.77 newtons per kilogram, or meters per second squared. They're actually the same thing. So I'm going to say that the force of my weight on Mars is equal to my mass times the gravity on Mars. So my mass is 45.4 kilograms times 3.77 newtons per kilogram. Okay, so let's see what that equates to. Times 3.77 is about 171 newtons. The kilograms dividing out. If I wanted to see what that was in pounds, I would take the 171 newtons and multiply by my conversion. 1 pound per 4.448 newtons. So I'm taking 171 and dividing by 4.448. And I get about 38.5. Okay, so on the surface of Mars, I weigh 38.5 pounds. On the surface of the Earth, I weigh 100 pounds. My mass on both planets is the same at 45.4 kilograms. Okay, I hope that that makes life a little easier. Okay, do the problems after this.